Hey guys, what's going on there? In this video, we're going to actually be taking on some exercises here. I've actually listed them out. So it's going to focus on how to interpret some of these models, and also I'm going to show you how you can actually apply random forest in machine learning. Now, I actually have two exercises here, which I'm going to be taking you through, where we'll create a data set for leprosy with age, household contact, treatment delay. Then some of the tasks we're going to do is we're going to train it with logistic regression model. Then we'll print out some of the coefficients. And basically, we're going to actually explain in words which of the factors that increases the risk the most. And also, we're going to actually create a pipeline, bringing in StandardScaler and all the other parameters for random forest. And we're going to actually use any of the neglected tropical disease data set. And also, I'm going to train it with logistic regression. That's with StandardScaler, train the random forest without scalar. And also show you, we're going to actually compare the accuracy and the feature importance in this data set. So we're actually going to jump straight into the video and into the practicals rather, and actually get the very best out of it. What I'm going to do now, I'm going to select my kernel. So the kernel, I'm going to be running it on Python 1.13.3, that's 3.13.3. And to commence from this project, I'm going to actually import NumPy. Okay, I'm actually running it on a Markdown. So to commence, I'm going to click on the code. I'm actually going to import NumPy as NP. Okay, that's the earliest. I'm also going to import pandas as PD. Okay, from sklearn.model selection, I'm actually going to import trinket split from sklearn.linear model. I'm going to import logistic regression. Okay, from sklearn.metrics, I'm going to import accuracy score. I'm also going to import precision score. I'm also going to import which other one are we going to be really interested in? Confusion matrix. Okay. All right, so that's what we're going to do for this video. Now, to get started, I'm actually going to seed my port. I'm going to say random.seed. I'm going to store that in a random variable. Then I'm going to actually, for this data set, to work with 700 data. And actually, we're going to check out this, and we have age, household, contact, and treatment delay. Okay. Now, what we're going to do from here now is, remember we're trying to predict the risk, and meaning that our target is going to be the risk. So basically what we're going to do right now is for the age, we're going to actually assign it. So we'll call the NumPy method random dot. So that's going to be 4. And the size equals then. Okay, so for half for the so we can say 0 to 7. And then again, next thing we're going to do now is for treatment. So we can set it from 0 to 12. For the risk level, this is going to be our target. So for the risk level, right? So because if you look at this, we're trying to which of them increases the risk, at most and all of that. But we can actually, for this is going to be, we can actually leave it as infection. Okay, I think that works better as our target. You can say np.where. So that's going to be whenever age is greater than or equal to 40, and also we can actually have our household contact is equal to greater than or equal to 4. I think that works fine. I can actually say 1, 0. Okay, so that makes the person infected. And I think we can add for treatment delay, since we have that variable, so we can actually say and treatment delay is probably is greater than or equal to 5. I think that works. So that's it. So the next one we're going to do, we're going to call our data frame. So what we'll do, so we're going to actually set it. So the next thing we'll do is LF DF. That's going to be, that's for the leprosy data frame, going to be data frame. So we call that constructor and we pass the dictionary instead of it. We have the age is going to be age. We have household contact is going to be don't have a I think we'll change this to infection status. I think that's actually a better word. Now that's that. So the next thing we're going to actually do, so we can actually inspect our data frame. So we check out this and this is it. Okay. And I think that works. So the next thing we're going to do now is we're going to now, and well, not encoding right now. We are now going to do what we call feature engineering. Okay, so to do that, the next thing we'll do is we'll now have our X is going to be the D, that's going to be the LFDF of. So we're going to pass another block there. We'll have age, we have household contact. Okay, we have treatment. We have infected. Okay, I think that you can see infection status on infection. Okay, let's use the word infection. I think that works better. Sorry for the changing. I think that's okay there. It's just going to be there in the data frame. Okay, so run this, no issue. And yeah, everything works. So for our Y, it's going to be the L2TF of infection. Okay, if we print Y, so that works. So this is actually the series of data. Okay, all right, so we're actually going to take that out. Sorry for that. So the next thing we're going to do right now is we're going to train our data set. Okay, now we're actually going to do a series of things. We're going to train our data set. We're going to actually perform some kind of training / splitting. Okay, so to do that, next thing we'll do is we'll have our X train. Okay, if I spell that correctly, we'll have our X test of our Y train of our Y test. Okay, so we'll assign that. We'll call the train split fit method. Pass Y and X, and then I'll have a random state at 45. Any random number will serve. Test size equals to 0.4. We can use 0.4 to train. Now, so the next thing we're actually going to do right now is we're going to train our model. So we'll do our model training. Okay, so to do that, what we are going to do right away now is we'll now pass in our model. So we'll create that object and we'll call it, so we're going to call the logistic regression, then we'll pass our maximum iteration. Here is going to be 1000. Okay, now we'll do our model dot fit, and then we'll pass in our X train, Y train. Okay, that works better. So we can now remember we talked about understanding doing the confusion matrix and also understanding the precision. Okay, so I've explained what precision is all about and confusion matrix. I'm definitely going to be dropping another video where I'll be doing some kind of theoretical insight on that. So so what we'll be doing now is, first of all, we need to actually get our preds. Okay, we need to do our prediction, our model prediction. And now to do that, we're actually going to assign this to a value. We can actually say Y preds is equal to model. We'll call the model object, then pass the method model dot predict, and then we'll pass in our X test. Okay, I think that works fine. Okay, sorry, I didn't get that. I think that should work fine. Yes, correct. Now, so what we'll be doing now, we're going to be getting our accuracy score. Remember, we want to make interpretation. Then we'll be getting our confusion matrix, and then we'll be getting our precision. That's our precision score. And also another thing we can also get now is we can also get the recall score. So what we'll do now is I'm just going to go up and also import the recall score. Okay, so this is actually very important in interpreting your model. Okay, and now what we'll now do right now, since we have all these parameters, is that we can pass this in, we can pass it in the methods for each of these. So what we're going to do now is we're going to print out that the model accuracy for leprosy infection prediction is, so the model accuracy is going to be, we can actually pass accuracy score, and inside of the accuracy we can now have our Y breadth and our Y test. Okay, so I think we can actually just reproduce this code before. This is going to be for our confusion matrix, and we'll pass it here confusion matrix, and this is going to be for our precision score. So we'll pass it here also, precision score, and this is going to be for our recall score, and we'll pass it and call it recall score. So we can print that, and that works perfectly. So this is the model accuracy 1.0. And then in terms of the confusion matrix for leprosy infection, that's 250 0 0 30. So let me actually explain what this is. Okay, now what this thing means now is that, just think about this. Like, I think I can just open a Word document on my home page. I can just click here and open a Word document so I can write on it. Now think about that that confusion matrix as you have a box like this, so probably box and something like this. Okay, so just think about this as true, negative, and this is going to be false, negative, and this is going to be true. So this is going to be false, positive, and this is going to be what? True, positive. So this is what this illustrates. Okay, so when you look at this confusion matrix, this is exactly what should come to your mind. Okay, I can actually increase that. I can increase that for more clarity. So what does this mean now? Let's go back to our code. Now what does this mean? I think I can copy that and bring it here. So what it means is that based on the data set, 250 people, right, that's what it means here. And it means that 250 people were accurately predicted to not have the disease. So I think I'm going to put a 0 here. I think I'm just going to take out this. Okay, I'm just writing myself. Let's say 250, and this means here is going to be 0, and here is going to be 30. Now this is actually more like a very perfect model. So what it means is that 200 people out of about 280 people who were used in the prediction, right? That's when you add this and that. Okay, so now it means that the model accurately predicted 250 people who do not have the disease, and also it means that the model also accurately predicted 30 people who have the disease, and based on false positive, which is what people who are negative, but it's showing that that's more like people who don't have the infection, but the model is showing that they have the infection. It didn't identify anybody as that. And based on false negative, right, which is people who actually have the infection, but the model is saying that they don't have it, the model recorded 0. So that means in terms of true prediction, it's actually a very precise model. So we're actually going to look at that other part of the explainability. And the precision score is 1.0, which shows that it's actually a very perfect model in terms of its accurate prediction of people who don't have the infection, and also people who have the infection. Okay, so recall score is still 1.0, which shows a very significant, passes a significant message about the model in terms of its prediction. I think we're actually going to continue because we're actually looking at interpretation. And one of the things we will now need to look at when we check out our exercises after training, we're going to actually print out some coefficients. Okay, so here, this is how our data set is. I just corrected this. X is equals to LTD, DF, age equal to household contact, and treatment delay. So this is our features for our data set. So please understand. Okay, so this is our feature. Now, so let's remember that this is what our features variables are, right? So that's more like the features. Okay, so now remember that we can just train our model again. Model is equals to logistic regression. Then we can pass in the maximum iteration to be 1000, and we can say model.fit. I will pass x train, y train. Okay, and now, so what we will now do right now is to get our coefficient, because we want to actually create the coefficients. So what we're going to do now is to get our coefficient, we'll say coefficients is going to be equal to, we can call it pandas data frame, and then instead of it, to pass a dictionary, and that's going to be for features. We'll see it's x dot columns. I think we're going to double string for the coefficient. It's going to be, so we call this method model.coef, don't pass 0. So we're going to actually, what we're now going to do next is we're going to print our coefficient. Okay, and that's it. So what it means here now is that for age increases the risk of leprosy infection by 0.14. That's almost slightly increasing it. Okay, they are compared to our household contact, which is a very, very significant. It's very significant in increasing it. Also, we've got treatment delay, which is 0.54, and that's like what it means is that when you look at this data here, you can actually see that of the three parameters of the three characteristics, age, household, and treatment delay, then you see that household contact is strongly increasing the risk of leprosy infection. So I think we're going to now move to the next one. And what we might do now is we might need to now use a decision tree classifier, so we can actually go up to check our data set. And here we've got our we've printed our coefficient, explaining what. So I really literally explained that. And what we can do now is we can import our pipeline basically to train our logistic regression with the StandardScaler and train our random forest without a scaler. So what we might do now is I think I can actually pass through this through the decision tree. So I'm going to say from sklearn.tree import decision tree. Ignore what this decision tree classifier. Also from sklearn.assemble import random forest. Okay, I'm gonna say random. Okay, so from the sklearn.pipeline, so we're actually going to import the pipeline model. Okay, and from sklearn.preprocessing, we're actually going to import StandardScaler. Now, what we might need to do now is we can actually do tree underscore model is what we can actually call that decision tree classifier, okay, and pass our max depth as, well, we can pass it as 5. Now this still works. We can actually have our tree model dot fit, and then we'll pass in our x train, y train. Okay, now actually we want to actually understand the accuracy of our tree. To get the accuracy of our tree, we can actually say tree, that's our tree training. We can actually tree training accuracy. We can now pass tree model dot score. So we'll pass our x train, okay, so we can print our tree accuracy. And yeah, that still works. Now to get the accuracy of the training, this is the accuracy of the training model. Now to get the accuracy of the prediction, what we can do now is we can actually do tree pred is equals to, now the reason why we're doing this, we can see, we can just put the tree pred accuracy is now going to be, now instead of passing our x test here, because we still have our y train and y test and x test, so what we can do now is we can now call the accuracy score, and then inside of the accuracy score we'll pass our tree, okay, first of all we'll pass our y test, okay, and then we'll now pass our tree model, okay, dot predict, and then we'll pass our x test. Okay, so we can actually now print our tree pred accuracy, and yeah, that's 0.99. Now what we might do now is, because we have variables like age. Now when you look at age here, now you see that age is at 4 to 70, we have household contact is 0 to 7, we have treatment delay 0 to 12. Now what this means is that it's important for us to get that for logistic regression, there are tendencies that those scales might kind of interpret with the data. So for age is like 4 to 70, and we have our treatment delay, which is set at 0 to 12. Now, but all of this, and also we have our household contact, which is set at 0 to 7. Now, essentially, why we want to actually use our scaler is that we want to actually create a pipeline, and then from that pipeline we can now make our prediction. But before then, what we might want to do is, remember, we go back to the exercise. We might want to now train our random forest without scaler. So everything still works fine. We have our x and y, our target and features. So what we can do now is for our random, so we're going to call it RF. Let's see, RF model is going to be our random forest classifier. Okay, so we can still pass the max depth there as 6 or whatever. So basically, the next thing we're going to do right now is, now we can now print. Now before we print, what we might do, now the next thing we will do right now is, because this same applies, you can see for our RF model dot fit, okay, we'll pass our x train, y train. And then the next thing we'll now do now is we can actually run that. That works fine, perfect, works fine. So we can actually, since we're using a random forest, so what we can do right now is, now to get the accuracy, that's RF accuracy, what we'll do now is we'll now pass in our accuracy score, we'll pass y test, and we'll now call that's the RF dot predict, rather we'll say RF model, right? Okay, dot predict, Then we'll now pass in our X test. Okay, I think there's nothing breaking, so that should work perfect now. So we can print our random forest accuracy, and that's 9964, working perfect. I think I can just comment this out and print that, and that's it. So we're going to actually initiate the object, and now we have our pipeline. Okay, and then the first thing we'll do is our scalar. Okay, it's going to be the standard scalar, and then for our model is going to be the random forest classifier, which inside of it we are definitely good. So I think, yeah, we can actually just wrap this. Okay, yeah, I think it works perfect. Okay, we can just wrap it inside. Okay, so I can just wrap this as well. Okay, so here we're going to have our n estimators. It's going to be at 100, and our random state of 43 or whatever. So I think that works. So we run it, and so pipeline is not defined. Okay, so we're definitely going to do that right away. And okay, so that works. I think I can comment this out. So the next thing we are going to do, the next thing we are definitely going to do is, now we are done with this. So we'll say the pipeline dot fit. So we'll pass the X string, and the Y string. Okay. And then I think that works. We run it, that works perfectly. You can actually see the pipeline for the standard scalar and all of that. So the next thing we'll now do right now is for us to do the prediction using the standard scalar. That's what we'll now do now, is the breadth, that I might call it the pip breadths. Okay, after training it, we'll now call it pipeline dot predict, and we might now have to now pass in the X test, run that runs fine, no issues. And then to actually get our pipeline accuracy, so that's going to be, we'll call the accuracy score, and then we'll pass our pip and our Y test. So we can print our pipeline accuracy, and that gives us 0.9648, and that's good. Now the next thing we're going to do right away is, I think that's just that for the session. Yeah, if there's anything, so probably we can just, to train it without a scalar, I already did that before. Basically I started, so to train the logistic regression dot scalar with the scalar, right? Okay, so to train the logistic regression with the scalar, what we'll do now is we'll say log pipeline. So I'm going to call it log pipeline is equals to. So the next I'm going to do now is going to be equal to, I'm going to call the pipeline class, then pass that inside of it. So what we'll do right now is here it means that for our scalar, it's going to be the standard scalar. Okay, and for our model, it's going to be the logistic regression model. Okay, we can set our max to be 1000. So I think that's that. So to train that, it's going to be log pipeline dot fit, and we can pass in our x train, y train. Okay, so we can run that. That works very fine, and we can actually now do our log bread. I'll call it log bread. It's going to be our log pipeline dot predict, and yeah, we can pass in x test. So what we can do in one line, we can rather write our for our log accuracy. So what we can do is going to be, we'll call the accuracy method, and instead of it, we'll pass our y test. Okay, and then we'll now pass our log pipeline dot predict, and then we'll pass our x test. We can now print our, that we can even print all of this. It's possible for us to shorten the line of code, and I'm just trying to just show you guys how to can print accuracy of our logistic regression model using the StandardScaler. So I think I can delete this and close this, and that should run. That's correct, 0.95. So now when you look at the logistic regression model using the StandardScaler, you can see it's 0.95. And then when we look at the logistic regression without the StandardScaler, that was model accuracy and 0.95, and I think this is 0.96. Okay, that's 0.95. So literally that's just it. For you, and here we have 0.6. So we can just compare. So comparing that is just to look at it. So we can actually use the decision tree classifier, but we don't use the decision tree classifier for our standard scaling. We just use the logistic regression. Yeah, that's actually random first. So guys, that's definitely going to be that. We've seen a lot of things, and the last thing I'm definitely going to do now is I'm going to check the feature importance for both the decision tree and the logistic regression. Okay, so that's going to be the last thing I'm definitely going to do. And to do that, it's not really difficult. To do that, what we're going to do first of all is, so what we're going to actually do now is we're going to actually bring that tree. I'm going to call it D tree. Just going to call it D tree is equals to the decision tree classifier that I kept the max depth at 4. So what I'm going to do now is I did a D tree. I think I can see that's the D tree model. Okay. So D tree model dot fit will pass the X train, Y train, and that works perfectly. No issues with that. And now what we are definitely going to do right now is now we're going to actually get the features importance of the D tree, of the decision tree rather. So to do that, so we're going to actually say the importance is going to be pd.data frame. So pass the constructor, and as usual inside of it there will definitely be a dictionary, and what's going to be here now is for the feature. Okay, it's going to be the x dot columns, okay, which is what we've been using, and now for the importance, because this is going to be for the features importance. Okay, then we can actually now pass in our, we can say here D tree, okay, D tree model dot feature importances. Okay, and that's definitely going to be that. I think I actually forgot the semicolon here, so we can actually print our importance, and that works very perfect. Okay, so showing that treatment delay, it's, so I think, yeah, what we can do here now is we can just dot sort values. We can say probably we can say by, probably we can sort it by feature then we can put the ascending as false. I think that works perfect. I think that's okay now. It's more clearer right now. So this is the features and this is the importance. So if you look at what I did before, you see how it was. Let me show you. You saw how it was, but by sorting it properly now, everything now is quite is now already well done. So it's not like we have our features here, and yeah. So basically, if I want to do this also for the random forest classifier that we did, so we actually identified that as the RF model. So what we can do right away is we can just I can just copy this, bring it down so that it's going to be seen. I'm just going to run it on this cell, and basically what I'm going to do now is I'm just going to create R importance. I'm going to call it R importance. It's going to be equal to bd dot data frame, and as usual passing a dictionary, and for the feature, I'll use the word features. It's going to be the x dot columns, okay. And I think I can actually use some small, and then for the probably for the importance, it's going definitely get. Oh, sorry. So for the importance, it's going to be RF. That's actually the RF model dot. It's going to be dot feature. I think I spelled that. If I spelled that correctly. Feature importances, okay, and I think that is that. So I can actually just print the importance as this is going to be the R importance, and that's it. So guys, if I don't want to have the index, this index here, what I can do now is I can do dot probably so string. I'll set the index equals to false. That's it. So that's that for today. I just want to say a very big thank you to you guys for supporting this channel. Remember to like and share this video, and do enjoy to engage it with your friends. I'll definitely see you on the next one. So this is just everything explainable, because machine learning is all about being very explainable. You write the code, you make sure it's quite explainable, and yeah, see you on the next one. Bye bye.